Hello there, and welcome everyone. Welcome to the broadcast. We're going to be doing some game optimization here today. Got a couple of things that I want to try, and we'll see if they work. Did a little bit before the stream, and I'll show you what I was working on. But before we do, let's check in with the kitties. We do have Ember across from the keyboard. Molly is on the side of the desk. Looks like Mason and Sherbet on the bed. Sammy on the shelf, and Sky is on my lap, soaking attention. Just soaking attention. But yeah, optimization today. Let me show you where we are. So the thing I added, we're going to need to do it to one more element, but I've added a visible notifier to our sprite here. Visible on-screen notifier. What that is supposed to be doing is telling me when an object leaves or enters the screen. For the purposes of visuals, I want to hide that object when it's off screen. So we're not trying to paint a sprite. We're not trying to draw it at all. This can be useful for the purposes of performance. With that code running, again, it's not hitting the shadows, which isn't perfect. I've sped up the yarn balls here so that we can see it better. But we're hitting about, let's say 800 yarn balls, more or less. And the explosion effect going. If we remove the explosion effect, we should drop down to a really respectable performance value here. Drop back to. So this is with like a steady 800 objects active. We can bump that way up. We can't quite get into our 5,000 territory, but again, if we get into 5,000 territory, performance can be lower. But next thing we'll do is we're going to attach that same logic to the shadows, so that we can verify if we're getting as much as we can out of this new logic. But we're sitting at about 20 frames a second with 2,400 objects. I still want to do more. It is absolutely possible to do more. We are limited by the more complicated movement logic of our projectiles and the like. There's a lot of optimization you can use if the projectiles are, let's say, dumber. As in, they're just a object that moves in a straight line over the course of its existence. Rendering can be made a lot simpler, but as well as the movement logic, but we can't do that the way that we're operating. Okay, so we need to mimic this on-screen visualizer stuff for our shadow, and so we shall. One optimization I did with the shadow is I'm no longer redrawing it every time we need to do an update. I'm changing the scale of the shadows node. This is because I found that this is actually pretty expensive. Currently, our most expensive call as far as frequency is the set position of the nodes, which is a known limitation. Like messing with where a node exists in the world is not cheap in aggregate, since we're doing it many, many times a frame. We could do that less. I do intend to put a frame per rendered frame limit, as in we will require that at least X amount of time has passed, and we will process no more than X amount of time. So if a physics frame is happening too frequently, we will skip it. if a physics frame is happening too slow, then we're going to ensure that the time does not exceed our target. So we might say the game runs at 30 frames per world tick, and a world tick will be like a visual frame kind of thing. Well, if we say the game runs at, let's say, 30 frames a second, then every game tick is 1/30th of a second. It doesn't matter if we get more physics frames than that, we'll cull it down to limit that amount of time or that amount of processing. But if the game slows way down, we still process the physics at that pace. So 1/30th of a second is processed every physics tick in this example. That means that if the game slows way down, technically the simulation is still happening at the same pace. We're seeing it at like 2 visual frames per second or half a visual frame per second, but we are still processing the world as if we were getting that 30 frames a second of physics tick. It's just slowed way down as far as the onlooker. Okay, so the shadow needs the same logic for that. We're just going to pretty much copy it over. The reason that I'm not making it part of entity visual is... Why am I not doing that? I should just do that. And we can have a couple of layers of function that we'll call in order to rig it up. Yes. I feel like this is a good universal. So I'm going to port all this over to our entity visuals. Now, they're not necessarily going to get used in the same way. As in, a particle will behave differently than a sprite will behave differently than the drawn shadow as far as what happens when the visibility changes. But we'll get there. We'll get there. Okay, screen notifier. So in our initialize, we are going to add that child there. Need to set the size, which we should be able to do yet. Right, if we create this one first, we can edit. Yes. Okay. And I'm porting this to be an upper level call that all visuals will have a notification if they're outside of the visual area. And we can manipulate them accordingly. We're going to have a series of these calls here. And we will need to wire up the position differently. Clean some of this up so that I am not searching for what I want here. Make sure everything is functioning. I didn't do that. Make sure everything is functioning. Yes, yes, yes. Got it. Okay. Okie dokie. And just a heads up, this might be a shorter stream. Sleep is a problem over the last week or so. And I've had some other engagements to deal with, which aren't necessarily helping, but we're striving to work through it. Full. Gonna need to deal with this as well. We'll need to have our own removal logic wired in to accomplish this. Okay. We are adding complexity. Adding notable complexity here to the parent object. Like, we're going to move this to be a triggered event, which will have the pattern of call the base. So right now we have things like trigger removal. We're going to need to move around. Okay. So when we need to get the create out of this. Texture wrapper. Okay, no, we don't. We are going to configure this. And this is after we've set the entity. Yes. These will be very similar things. Call you a virtual. Yes. You are a virtual. And void. We're still going to do this logic. And the same way here, we're going to remove it in the same fashion. Don't need any base for this, I think. Oh, we can save some effort here. Yes, okay. We're getting there. We're getting there. Entity, visual, sprite. So we no longer override. We call the base. So in this case, we need to make sure it comes into existence. And what we are going to do here is we're going to set the size of it. It should already be in existence. If it is in existence, we're going to set its size. We're not going to mess with the sprite. We're going to mess with that whole parent node up here in Entity Visual. Here. False. Okay, so we are not rendering if once we are immediately created. We get rid of the visibility on it. And when we become visible, we set it to true. When we cease to be visible, we set it to false. This will become relevant. So we don't need to do that. We are adding to our create visible to set its size based on the sprite. We don't call you. We don't do this. Could have set offset. Apply offset. Okay. Hey there, Schmuggums. Welcome. Working on our game today. Doing a little visibility work here. Don't think this part is actually right. No, that should be. As it's sleep issues, Schmuggums, it tends to be there's a series of compounding things, but getting the momentum back. Last stream was definitely truncated. We stretched it as long as we could, but the game was... I didn't do enough research, and the game was way shorter than anticipated. So instead of doing a clear and taking extra time, expecting a clear to take the whole time, the clear was straightforward, and then we did a complete clear to stretch it. We're going to be trying to get some of our creepy camera games in for the month. See if we can get some fun stuff. Yeah, bad sleep can really kind of pile on problems. Okay, we don't actually want it to be at sprite position. It's a little different. So that's its size, that's its position. So we shouldn't need to actually do this. What we're working on right now is we're creating triggers for removing the rendering of things when they're off screen. Yeah, there's... For me, at least, the collapse period is before 24 hours. I know there are some folks that are proud that they can get past that. It's not a good thing. We don't need to care about first draw for this. We need to redraw. When it comes around. And then we just update the scale here. If we get this far, the entity is not null. So this is one of the tricks we did to optimize shadows. Draw circle is not cheap. And while we're doing it in on draw, it's if this is present. It doesn't mean it's being called every visual frame. What happens with on draw is that it will only happen again if a redraw has been queued. And there's nothing about a drawn circle that fundamentally triggers that again. Previously, every time we updated the position, if the height changed, we queued a redraw. We're not doing that anymore. We're just changing the node's scale. So we should only get the one for a given entity initially. Well, I broke it. How did break? We should be setting the node to visible again. We set it to false. During our entity visual here. False and true. I'm going to expand this out so I can actually see it happen. Okay, it's not immediately happening, so we are going to set that way and just verify. Might have had it wrong. Okay, we get our initial shadow draw, and we have entered screen. Shadows for yarn ball. Okay. Okay, the sprite is not being set visible, and that is because we are culling the sprite initially when we create it. Down here. Okay. Well, given what I saw there, I may have had the logic not quite correct. So we're going to double check that we're getting the result that we want. Oh. Go to entity visual. check. We need our onRemove in here as well, because we're creating multiple visual triggers this way. Okay, so when we are currently in Sprite, when we set the entity, we are Hey there, Cruel. Okay, Sprite is overriding set entity. We're getting all of this stuff in here. This needs to move up. This needs to move up. We should always have these wired in. And we'll have them we'll make these virtual. Because we are storing the entity, there's not a reason to... yeah. Huh. There was some redundancy there. Don't need to do that. And we're going to take these, and we are for move entity and position changed. Yes, there should always be on remove entity. We should always have this, this, and this. I'm sorry, no, not animation changed, but position and remove should always be marked. Equals that on remove entity. U equals that. Equals tab, change name, call you a virtual, you a virtual void. Okay, if we don't do an animation change, that is part of the other one. Entity is not, no. Actually, no, we're going to leave it that way. These are technically good fail-safes, like in many programs you want to have sanity checks. Hey there, horse. Welcome back. How much chunks could I have optimized? We're still working on... We're going to get back to that one, Cruel, where we subdivide the map and only process new rendering logic when we get to that portion. But I need to see how much I can load of the map before it becomes a problem, so we can get an idea of what a good chunk is. Called base, we do all the logic for that. Position updated by default does nothing. On remove entity is going to pull these methods off, and it's going to trigger the removal of the visible notifier. We'll do that. And then we're going to remove visible notifier here. So we have entity, move, entity, position updated, remove. Be creating Linux input system fate. Intercepting system level operations like that is fraught with peril. A lot of third-party single sign-on software. You'll see it used for like, hey, I can log into a computer with a tap badge. A lot of single sign-on software uses that same kind of intercept logic, where it will kind of worm its way into another program to do things like find login fields and similar. And that can play... that can wreak merry havoc. So you get weird errors and failures in the logic all over the place. That we remove it. We remove the visual notifier. Then we're going to invoke remove entity visual when that happens. We don't remove that here. Move the entity. We don't need to do trigger removal here because we're going to, in the visual, invoke remove entity. We're already doing that. We're already doing that. Removal doesn't need to remove entity because we're already doing all the stuff we should be doing there. We should just remove the sprite, which, given that trigger removal has no other logic, we just remove sprite. All right, what did I break? Okay, so we are going to flood the area with these because we saw that we were getting aberration after a bit. That aberration triggered once the node cache cycled around. Right there. Okay, when an entity visual gets its node, we have to set that to true. Make sure that's in there. Okay, the explosion texture is not rendering properly. Flood this faster. Okay, we've got some of that laid out. Now we need to look at single animation feed events here. So the play once one. Check what we were doing with it. Or we were calling trigger removal. Previously, that would do entity and invoke. When we removed entity here, we're getting that the sprite, the removal of the explosion is taking too long. I'm sorry, is too fast. I'm not sure I understand that last line there, Cruel. What did we do that could be going wrong here during this? Hello, Tazzy. Welcome. Okay, we're getting some of them, but they're not playing. And we're not getting into sprite animation finished. Did we accidentally remove this? On remove sprite and on create sprite, we do sprite animation finished. Sprite play here. We should not be adding the child here. That'll create a duplicate. That would be a problem. Once again, getting some of our explosions not playing properly. There are GPU level optimizations we can do, but those are going to wildly increase complexity for the time being. There's something fundamentally going wrong with those explosion sprites. We can see some of them are lingering when they're not supposed to. And the issue that, like, that is triggered here. Like, we're never hitting that little bit of logic. And if we don't hit... if we don't go into this, that's not going to properly pull those out. This implies that the sprite is being removed. Okay, we're going to go in here. Okay. So it's not that remove sprite is happening early. It's that we're not getting into play once. Okay, we're never actually getting into sprite animation finished at all. We have attached it. We know we're not getting into there before we should hit this. Get our visual sprite. We copy over play once. Should get a few of these. A lot of these that get loaded up. We should get a copy. I could add an if to this. Weird that we're getting that many copies going on here. Okay, these are the blobs being triggered. Let's... just gonna short circuit this. For the time being. Okay, the play once on the explosions is not getting through. But how is that? By default, it's false, but we propagate it in our bullet logic. Explosion, center sprite, play once true. These should exist. We're wiring it up. Why is that happening? Additionally, to me it's indicating that that entity is... So the explosion isn't appearing, but it could be that the explosion entity is getting removed early. No? Oh, that's extra weird. Oh. That entity... Oh, there's on remove entity. So that should be wired up. Alright, that's what was happening. This causes that visual to be fully removed. We need to get this elsewhere. needs to happen after we get done with the whole chain. And we could queue it for removal, but yeah, we fully pull it here as soon as this happens. So that visual is in a weird place as soon as this happens. So the entity visual cannot invoke this where it is. And I could queue them for removal. Like I could have a cache for it, but these don't really have a timing aspect to them. These just do what they're supposed to do. So we don't have a location to get the caching in. So what to do about that? I mean, this is not a great pattern here. But if I were to go in and instead of base being here, base is after. This is a landmine if it's in this way. It really is. And it still don't work. Now we can see that the entities are removed. So those blobs are getting culled as it goes. But we would still need to get into this, and we're never seeing that called. That is still a problem. And we're never seeing this set. How puzzling. How troubling. Well, it's kind of good that this didn't change it. Once again. Put you back. Put you here. That there, and we go in and put this here. Oh. Oh. This was never happening. That override is not the one that's getting set. It's that one. And only that one. So if we look here, I'm calling on remove entity, the override exists in here. So an explosion goes off. Almost immediately, the remove on that happens. We call all of this information, we remove the visual one, and then we invoke remove entity. And we finally get to remove sprite, but that happened many times. How and why did that happen many times? Oh, it's a bullet. I'm sorry, it's a particle. Okay, that's... Huh. Okay, this is good though. This is good though. Still potentially good. Okay, so now we need to get particle in there. The particle, we add the particle child. Don't do this. Not gonna do that. We shouldn't be messing with the node's position here. A lot of this cruel is seat of the pants, and that's kind of intentional. If I was doing this as like a professional project, I would be doing a lot more commenting. I would have things like design documents set up, and we may still need to circle back around to that. that. We don't do that. Which means we move you to here. I just do there? I didn't think I changed on. The animation changed. Okay, I did. Similar here, since we don't need animation changed on particles for now. Care about released. So if we call remove particle, clear out all of that. Okay. We still potentially have this issue, but in fact, I'm certain we still have that issue. To some extent. Okay, maybe not. Maybe not. Let's... our base call in there. Okay, there's our problem again. So if we move you to here. So if this is what I have to do, this one needs to get commented like crazy. Because that's a landmine. Nope. Oh, wrong function. This one. See it fire or not. Same issue yet. Because we are getting in here properly. But this one is still triggering first. If I remove my call to this, the problem being is we're not disconnecting the entity logic properly. That's not the end of the world, but it's also wrong. But this should have changed that fundamentally. Didn't I? Yeah. you here, and we put you here. Unremove entity, and then the base. Okay. All right, we need to look at that a little more. We're going to take a quick break. I will be right back. Okay. So as soon as this happens, the entity's going away, but there are some of the particles are not rendering at all. And some are lingering in a weird form. Just before we would trigger removal. Which set released equals true, but that didn't do anything. That was vestigial. We would untether the entity, then untether the particle, and then invoke the removal. But wait. If we're playing once, if not play once. That's the problem, I think. Okay, particle is a different animal entirely. It doesn't care about removing the entity initially. Technically, this is just an overall problem. But the particle doesn't do this the same way. Okay, particle is very special. It is only when remove particle gets set when we're gonna call. Yeah. That. Hey there, James. No nano spill yet, but, you know, it's inevitable. Okay. That's why. Okay. Ugh, tricky. Okay, so when we get an onRemove entity signal, if we're calling play once, then we're going to say, oh, actually remove the entity, and then remove particle. Because we don't want the base onRemove entity to trigger until the particle says we're ready to go away, because the base visuals removal here is going to invoke the removal of the visual. This is the entity is gone. Get rid of this whole thing. But particles are different. They don't care that the entity has gone away one way or the other. It's, if the particle lives for the whole time, yes, it goes away when the entity does. But if it's a play once particle, it doesn't care that the entity went away. We don't remove the visual until the particle is done. Okay. We have the base onRemove entity. We don't need to call it here. Yes. So this is the tricky element. A particle could exist longer than the entity does, or it could exist for a shorter period than the entity does. A sprite, unless it is a play once, exists for the whole duration. This is stream 148, Cruel. So kind of half a year-ish. Probably plus a bit to account for some development offline. But this is kind of a let's all learn together operation, so I'm not doing it near as quickly as would be possible with dedicated game dev. Like, heads down offline, I could move a lot faster on this. But that's not how we do it. Did I actually fix this? Will it explode? Nice. Okay. Particles are wired in. Hey there, Sublime. Welcome. Yeah, I'm more fond of C# than GDScript, if for no other reason than the control over the better control that I get out of that. Okay, this is with super gratuitous. None of the projectiles are leaving the screen, so they exist for their whole lifespan. So none of the optimization that we did matters right now. About half a frame per second right now, or less. But that's with about 7,000 things. Halt the game. With no movement happening, with those things being rendered, we can get back up to about 20 frames a second. So we are going to remove the spiraling. So the ones that are orbiting are going to steadily go away. And then we're going to get the optimization for things leaving the screen. We can see the streamers going off in various directions now. So we're going to get a similar number of things, but they're leaving the screen, so we won't have to render them. This is still too many to be reasonable, so let's cull it down to merely too many. So we're going to let them spiral again. For those unfamiliar with the project, we are making a Survivor-style game, so in the vein of Vampire Survivors, haha, vein, vampire, but with a Noida kind of build-your-own-weapon kind of vibe. Okay, we get back up to about 15 frames per second if we are operating at about 2500. Still not great. But now let's let them go off the screen. So we stop rendering them once they're off the screen, in theory. So now we can get back up above 30 with this many objects. Those yarn balls are going to live for several seconds off the screen. I've doubled the movement speed of everything. Hey there, Daniel. I'm glad you find it interesting. As I was just saying, this is kind of a co-learning operation. This is my first major project in C#, my first game dev project, first time I've touched Godot. We are on stream 148. I do some research in tampering offline, but not frequently compared to the time that I spend on the stream. So we're not moving super fast. Okay. So numbers above my right ear. Partially obscured is the number of things that exist. So Like every blob, every yarn ball, the player character is a thing. No functional change to the lore, Cruel. And then above that is the number of frames per second we're getting as far as rendering is concerned. Which, if the rendering frames get too low, then it will throttle the physics frames as well, since Godot physics frames are tied to maximum per visual frame. Huh. I need to change that. The shadows are twisting to go with the sprite in some of these. Yeah. Maybe it's just an no, they're twisting a bit. Or are they? I think it's just an optical illusion. Feels like it is, but it's just an optical illusion because of the frequency of the redraw or the scaling. I declare that to be true. Okay, let's get ourselves in a position here. So we're trying to maximize the number of thingies on the screen at once because... So part of the background of this game, of this channel, is that we used to play a lot of Noida. A lot. And I ended up making a custom mod for it. Part of that mod was completely, well, heavily altering the viewer interaction thing that was built into Noida, because that's the thing was built only to do Twitch chat intercept. And Twitch chat intercept is super easy. It's an IRC feed. You can just grab the text as it appears. YouTube chat's a great big hassle. So we got all that wired in, and part of it was a bunch of custom stuff that aligned with avatar lore and what have you. But back to the point, our goal was not to explore the Noida world. Eventually, our goal was to reach the traditional final boss of Noida, the monster at the bottom of the world, and see how hard we could hit it in one shot. And part of that process, one of the running gags of the channel, was that part of the indication of success was how long it took that single massive hit to play out. Because that kind of hit required a great deal of processing. So we coined terms for the channel like minutes per frame. I think our biggest record was about 5 minutes per frame. Without the game crashing, I should say. The game crashes, it doesn't count. We want that same spirit, is that if the random elements of the game allow you to get something that sends your weapons completely out of control, that's okay. That's by design. We want that to happen. It doesn't mean that the game will remain traditionally playable, but part of a weapon going out of control is that you are functionally invincible once it happens. So again, from a gameplay perspective, from a design perspective, I don't care that you're getting like half a frame a second or something like that, because you win. You've already won if that happens. So, you know, if you manage to pull this off, just this, like, it's going to be really hard for the enemies to approach you. And we're getting over 60 frames a second, which is kind of our gold standard here. If we increase it out and make it that much more absurd, again, so our frames per second start to plummet. I mean, if you, additionally though, if you really love optimization, at the most granular levels, you could use C++ and machine code in order to get down there to the nitty gritty, like directly interact with graphics drivers. I don't wanna. I really don't wanna. I will find optimizations elsewhere. But despite the fact that we're getting about half a frame a second here, you win. Like, you just straight up win if this happens. There is such a saturation of damage happening on screen at the moment that it would be irrelevant how many enemies appear. So, we can see the player is wading through the blast. The nature of it is such that you could get hit at this point. But if I move and pause, the blast wave catches up. Right, Sublime. And memory management, like controlling how and when objects enter and leave the tree, in Godot terms, is along those veins. It's really expensive to get rid of something once you make it exist in Godot. So, despite the fact that it's going to look kind of nightmarish here, let me show you on the Godot side. There's shenanigans happening in the background to get as far as I have. So we're going to make a bunch of things. We're going to go over to the Godot side and we're going to look at our in-game tree. So we have our various renderers going on. What generates the map tiles? What's generating the drawing code? So one of them is all of these nodes here. Lots and lots and lots of them. This is a caching structure, so I make some of them in advance, and I don't rip them off of the tree when I'm done with one. We just put it back in line, and I can use it again later. See, these are ones that are popping in and out of visibility. Which is demonstrating that my visibility code is working. But all of these are lined up and ready to be used as needed. Oh, hey. What are you? What are you? There's a tiny orange rectangle that's not supposed to be there. Oh, I think I know what that is. Well, have I ever experienced memory leaks? Constantly. In various forms. Part of the reason that I'm not currently using coding languages like C++ is memory leaks are less catastrophic, and I don't have to deal with fun things like segment fault. Why don't you just port it to insert language here? Okay. On update position, we need to handle visual here. What is the gaming get good concept? The boss isn't difficult, just don't get hit. Okay, it's when the entity's position is updated that I care about the visual element. So when we update the position, we also need to update the position of the visual box. Okay. So during update position, I put that. What? So for a sprite, it should be... No. Oh yeah, that should be the case. Okay, this is where we set its offset. So this should be moving with the entity. But is not. Okay, experiment then. Times visual scale. Technically, Cruel, we are using multiple languages here. I'm avoiding GD script logic, but there may be instances where I can't dodge it. We've also been using some of the Godot shader language. But if we mean in general, like, would I choose to do that? Absolutely not. I would avoid that like the plague. Again, if there was not a functional reason that I needed to do it or that it would be good, I would avoid that. So, hypothetically including a scripting layer on top of it, could be useful from the modding perspective. But I want to minimize that. That's just an extra layer of complexity that we've already got to deal with. What was that? Oh, okay. We wouldn't see it here, we would see it over here. I know what the errors that the Godot thing is mentioning are. Okay. I don't know what that was. Could that have been? Huh. Okay, let's turn that off. Reduce variables. All right. Those 401 Godot errors are these single blocks right here. The hacky code for rendering all of these blocks here, the interconnected colored ones, is assuming more blocks than this. It's trying to load these as chunks, and that's not what it do anymore. Okay, what next? What do we do next? Okay, got good optimization. We've got an extra nice little bit of optimization stacked in. That's good enough for now. And again, we could see them popping in and out of visibility as we needed. I would have liked to see some of the sprite ones, but the fact that the nodes were being set visible or not, I think helps. What are some other things that we can do? I mean, I could proceed with more game logic, get the rest of the map renderer going, but I'd like to add one more thing here. So in the core game object, we have our physics process, we get our tick here. So if we're not paused, we go in and we're going to pass a delta. But I don't really want it to operate that way. Well, it's going to effectively operate that way, but okay, so we get our accumulated delta here into our physics process, adding our debug stuff. But if we're not paused, we are actually going to take this delta and do something with it. So, fun idiosyncrasy. Inside of GD script, inside of Godot proper, delta is a float. For reasons unknown to me, it converts that float to a double in the transition across the bridge to C#. But all of the APIs for Godot that you pass something like delta into, like you use it as a fraction or similar, all of the APIs in the Godot side use floats. So inevitably, when you get this, you are converting it to a float if you're doing anything on the Godot side. So why did they make it a double? Maybe there's some memory optimization thing that they decided to do. Anyhow. For now, is that the moment is greater than, just hack something in here. 1 divided by 30. Sure that it's forced here. Come on. You can see fun things like I don't use the prefixes like G and L, but you can see elements of the era that I learned programming in. Things like private member variables are prefixed with underscore. Said I no longer use the G underscore and L underscore patterns, and I no longer prefix them with their variable types because we have strong typing. But remnants of habit. Okay, what this is saying is no matter what, physics operates in ticks of 1/30th of a second. No matter how fast they happen, no matter how slow they happen, it will only ever be in ticks of 1/30th of a second. This will cull some of the extra operation we're doing. Because physics ticks are not cheap under this system. Hello, Sammy. Okay, reasonable. That has reclaimed about 10 frames a second. It wobbles. It wobbles. Chile. Reset the timer entirely. Yeah, I mean, we're still spending the time just to look. Like, the mathematical operation of messing with the variable at all is not free. But I can tell you with certainty, checking it is way cheaper than doing it. Like, way cheaper. This technically would introduce a bit of stutter, but it should be invisible. Not a lot of change. But let's put it back and get a point of reference. What? Oh. I get what it's doing, and it's annoying. Another thing from way back, I recall a professor who joined the faculty and really wanted to start branching out in the kind of stuff that was taught. And one of those things was OpenGL. One of the things that made this professor very fun was that they were just getting started. in teaching. Like, they weren't a fantastic teacher from a purely academic sense. They were a fantastic teacher to learn under. But doing low-level manipulations with things like OpenGL is a huge hassle. That one of the memories I have of that professor is in a closed book written exam. One of the questions was render a textured T, like capital T, the letter, like render it out using vertices, using direct OpenGL calls. It's not difficult, but it requires a whole lot of lines if you're doing it manually called. Every vertex would require about 3 calls to properly bind. So it was a simple question, but it required about 3/4 of a page if you didn't write like multiple lines per line kind of thing. Yep, it was stuff like, hey, begin rendering. Here's a vertex. Here's the lighting for it. Here is the texture point for it. Okay, here's the next vertex. Here's the next vertex. 6 one way, half a dozen the other with this. Not worth fiddling with. Oh well. It was a thought. A thought we shall not pursue further. In particular, I was referring to they're very expensive. These two right here are pretty much the entirety of our processing time. I mean, technically, this one is not cheap either. It is in a similar vein. But this one is really expensive. But I think right now... Debug... I think right now we're kind of Godot throttled. To get more optimization out of things like physics, I would need to be going in creating all of the collision shapes in physics and similar, like the sprites and whatnot, would need to be manually created using the lower level servers in Godot. So right now they're node based. Every one of the sprites, every one of the shadows, all of those are Godot nodes. That's not free. That's not free at all. But we can work with it. We can work with it. I feel like we're in kind of good enough territory. So if we end out here, show you what I mean by Godot throttled right now. I can't create the illusion of physics in this, and I will talk about that in just a moment. This is the guy right here. This is moving the actual nodes around is costing me. To avoid this one, I need to use the servers. Okay, illusion of physics. That is because of... Where did I put that? This guy. So you probably noticed me dragging and dropping boxes around during those tests to make more things appear. That is driven by our actual loop. Where's our handle message? Pretty sure we should have a handle message. Do we not? Oh, update. I should change the name of this. Entity. Yeah. Everything gets a time passed message when we call an update. And in that time passed message, we pass that into each entity. Each entity has a list of behaviors that it uses. So our little blobs. Oh, where did I put? Oh, it's in the spawning logic. Didn't hear, didn't I? Yeah, here we go. Okay, so this is a very primitive example, but when a blob spawns, I say this is what a blob looks like, how much health it has, that kind of thing. Then this is what that blob will do. It just moves straight to the player. Notably, it doesn't hurt the player right now. It just moves at the player. And we have two of them here. What I could do is I can make it so that there's more of them. They spawn more frequently. They have different damage numbers. But in particular, move to player is calculation. If the player moves, the blobs move. If the blob is in contact with the player, I need to trigger events based on that. We trigger iframes, we trigger damage, we process that damage. Now, a more complicated example is a weapon here. So, bullets have lifespans. They cause damage. How they move and the movement of those bouncing yarn balls is two different steps. So every time we get events, we roll through these and say, what happens next? What happens next? This is all in service of getting this Noida-like weapon modification. So I have a yarn ball. By default, this is what it does. Leaps up, bounces along. Super ineffective weapon as it is. This is for testing purposes. But if I add this one, now it spawns in bursts of 3. If instead of that one, I put this one on, it's going to move in these slower loop-de-loops. It's even less effective as a weapon. But if I do this, it's going to be in bursts of 3, and each of those will fan out into 3, and then it will try to orbit the player. So this is still bad, but it's more effective because the bouncing is going to happen frequently in a big ring here. But notably, every time time passes, I have to iterate down this line and say what happens next. Because I might have an effect like this one. Which says, after 3 seconds, it's going to fire in a burst. It's going to emit a burst of 3 that splits into 3 that orbits the player. That attempts to orbit the player, notably. They don't live long enough to actually orbit the player at the speed they're moving at. But this one is operative. Every time I come down a line like this, I might hit what I call a gate. And that gate might open, close, go away, based on arbitrary conditions. So I might have things like this where it's wait 3. I might have something that says after the first collision, now let things through. There are all kinds of stuff, all kinds of different things that I can do with this pattern, but it's expensive. I can't do bullet trickery like the sprite is placed at a fixed location. There isn't actually a object traveling. We just say, is there an enemy right here? No? Okay. Let the vector continue, kind of stuff. What that means is that everything is a tracked entity. Even explosions are tracked entities. What do we have for this? We can make it ridiculous in a different way. So again, this fan that happens is coming out and saying like, okay, split into 27 yarn balls on being emitted. And then after 3 seconds, the behavior changes. Each of them will emit in a 3-shot burst from where they were at the time that happens. It's a bit of smoke and mirrors. How that works is that it doesn't actually emit in a burst. The original projectile continues along, and another projectile appears at a regular interval where it was when that triggered. So if you're walking when a burst fire happens, if you're moving fast enough, you can see that the burst continues where you were standing. Nature of the beast. This is why some of the standard performance optimization doesn't work for our system. Because we don't want it to work in that way. We want it to work in this way, and there is an expense. So we're always looking for manners of optimizing what we're doing, but we can't change fundamentally what we're doing. Okay. What next? Make sure I don't have anything extraneously changed. So one possibility would be to have iterative states. So instead of all of the stuff happening in one big burst, we would have things like, okay, first I update the physics on this physics tick. I update world position, essentially. Then I update collision. Then I update map rendering. So kind of a 1, 2, 3 kind of pattern. So we might do like this chunk as a middle chunk, this as the next one, and then say this. That's not a good division, but hypothetically. So being helpful, IDE. Regrets about coding? I wish I spent more time on learning design patterns. It's not infrequent that somebody will mention why don't you use 3-letter acronym to help solve this? And I won't know what it is. My knowledge is all over the place as far as knowing the current trends in similar. Right, Sublime. Right. That's kind of where I'm thinking is, can I space this out a little bit? Can I reduce the amount of work going on at any given step? So we're going to experiment with that a little bit. So this is not 100% accurate. Let's do... Okay, first state is going to be check collisions. Check collisions doesn't require a delta. Then we're going to say we have a time passed message. So this already is going to smush down the system quite a bit. And for these purposes, we're going to say all of this happens. Okay, we check for collisions. Then we're going to update the world state. Then we're going to do like, hey, does the map or camera need to be different? Super choppy. Should be moving way faster than this, though. We are greatly truncating the amount of processing we're doing, actually, though. Massively truncating it. Now, I could accumulate the delta as far as the world state is concerned. But this gets us into trouble here. Not really, though. Map renderer doesn't... The map renderer just needs to tick. It doesn't need to know how long we have been. But let's... Again, this is really hacky right now, so... Okay, we're going to do a left-right. Again, we're still throttling it like crazy here. Well, that's not right at all. Oh, we're never culling last delta. Do. Because this won't really work for us here. This puts us into that nasty inconsistent territory where we're losing time, essentially. Hey there, Microchip. We're working on our game project today. Let's clear this. I know the get interface is over here too. I'm just so used to using the GitHub interaction at the moment. For a while I had my own like little Get repo set up on like a Google Drive kind of scenario, but thank you, Microchip. I appreciate it. And hello, Saludo. What can we do to clean this up? Thank you. Thank you. For those that haven't seen it, there you go. So this is our most expensive part. What if we actually throttle the time steps further? Let's do that again. Simply as a float. I've tried to code in Python. No, I haven't. I haven't tried to code in Python in general, outside of just like poking it. I mean, I've heard a lot of people do. Oh. Well, that's worse. I feel like, Sublime, that there's a lot of folks that feel that having super dense code is, like, extra good. And I don't really agree with. Oh. Do we see the problem? Oops. Every half second, send no time passed to all of the objects. Twice a second is way too slow, but, you know, for science. Go 3 to the 6th projectiles per second. Okay, those explosions are going off. Definitely off target. Hey there, Calamity Knight. Okay, well that's way too slow. We're just seeing what happens with it being super slow. So for reference, again, every second, 3 in quick succession, then split into 3, split into 3, split into 3, split into 3, split into 3. We're creating a lot of them very quickly. Okay, we can still see that the explosions are going off center. I don't know why that would be. Because they're being emitted from the player. So do 10 times a second here. So part of this is feel. 60 frames a second is where I want the game to run. That doesn't mean that the simulation needs to run that fast. Well, 30 frames per second is the target. That's pretty nice. Yeah. That's not bad. We could go a little faster than this. So that's still really smooth. Get our kind of our gold standard going here. Okay. We're sitting at about 800 things, holding really steady. It flickers, but more. Okay, we're entering calamity case scenario. As in, if you achieve this with actual weapons in the game, you are practically invincible. As long as you move slowly. I was mentioning earlier that the behavior of the projectiles is more complex than is something that we could just kind of fake the physics of. And you can see that when I walk forward. It's subtle, but if you watch the whole like mass of them kind of whips down and around, because the circling logic is independent of the rest of the logic. Those each of those projectiles is trying to move outward from where they were emitted in a random direction towards a target that was selected at random. So one of these blobs gets picked as the target, and that yarn ball tries to fly at them. Well, each of these spreads angles it off of that target. So 2 of them in a spread of 3 will not be aimed directly at the target. They'll be 45 off. Then this orbit is going to pull them into a counterclockwise spin around the player. So there's conflicting forces going on sometimes. Especially if I do something like add a sine wave. So you can see that the edge of it is getting erratic. Because on top of trying to get in that orbit around the player, it's now pivoting up and down as it goes, distorting that further. So that whip around takes longer to recover. We can see that there was like a mass of them spinning around before it leveled out again. Zigzag is very similar to the sine wave, but it is more of it's kind of a hard metronome tick. 45 degrees left, then right, then left. So we're getting a bigger distortion at the edge. You You can almost see there's like a central tornado. But I'm liking the results there. We're getting good results. This is the true Calamity edge case, though. Every second, each yarn ball emits an explosion right now. The number of entities doesn't properly reflect when you're dealing with explosions. Explosions live for a single frame. So right now, that's 1/15 of a second. Is how long an explosion lives. Its particle effect will live for about a full second, give or take. So these explosions live for about 1 second of rendering time on the screen. So they're going away before they complete their whole pattern here most of the time. So we have this sort of like ring of circles at the bottom. This is true. This is a more true I win state. It's hard to move at all, but you can also see the swing around that happens here. We reduce the number of projectiles, you might see it better. Still kind of ugly, and it'll take it a moment to recover. These are trigger effects. So, mechanically, what this one does is it looks at the next weapon and takes that weapon. So instead of the explosion triggering as an independent weapon under our feet, once these fade out, you'll see it again. You'll kind of see it again underneath the yarn ball mass. The explosion is happening right under the player. It's an independent weapon. But if I put a trigger on it, or a kind of, if I put one of these effects on it, it will grab that subsequent weapon and use it itself. So let's put a spawn of 3. So now we're triggering 27 yarn balls that will orbit the player. And then each second, we're going to emit one of these explosions. And these explosions say, after I am created, trigger 3 times. 1, 2, 3 in quick succession over the course of a second. So we're getting this fireworks pattern here. And so in the world right now, there's about 300 things in existence, plus the explosions. And again, the explosions live for a single physics frame. The entity that is the explosion, the equivalent of a bullet, lives for a single frame. So that update up there doesn't reflect it very well. We could do that more accurately, but meh. If I wanted to do it more accurately, I would check the count at the end of each tick, and record the count of entities instead of waiting for the debug update to come around. Okay, I think we have a pretty good pattern here. We'll make this a constant. Divided by 15. do it that way, we can clear it there. Hey there, Wukong. Welcome, welcome. Okay. This was actually pretty good. Pretty good. I like that. Double check again. We're going to remove the more complicated movement from the equation. 4th, 5th, 6th. Lots of projectiles at once. Why do you... Oh. It's... How's it going today? Pretty good. I'm not familiar with that error code, Cruel, no. Let's do 15 again. Bleed off. I spend a lot of time on this operation here because it lets me generate a lot of things, and I want to get an idea of how many things I can have on screen before we get problems. Well, in the world before we get problems. Like, what is the threshold? And right now, more than 3 to the 5th per second is doable. Well, 3 to the 5th per second being created and then a similar number eventually being destroyed. So there is a accumulation period in there, but 2,400 things is running at well above our target. If we can stay above 30 frames per second, then for a pixel art game, we're in good shape. Pixel art game where we're not trying to do like frame perfect parries, you know? Okie doke. We are getting there. We are getting there. Okay, let's store that off. both a minimum and a maximum. It's at least this much time has passed, and no more than that amount of time will pass before a physics tick. It's a little wiggly on the edges, because it's possible that we go a little over that threshold periodically, and the next threshold will happen a bit faster. But that should usually be invisible. Both because if it's fast enough, you're not going to notice the idiosyncrasy. If the system is going slow enough such that about 20 frames a second is wildly overrunning, then it's still going to be slow. It's just that the simulation won't lurch as much. Okay, so then when we look at our map tile renderer here, we could actually start to go back to our map shader renderer under this model. That still requires a little bit of footwork to use the shader renderer. We can see some of that footwork described here. The difference in this is that this one requires a bit of a shell game with things like what it's rendering on and where it's rendering it, that kind of thing. And I want to get the map tile renderer all ironed out and clean before we look at putting those tiles into this. So first we're going to remove the idea of chunks at all, and we're just going to repeat the image. And we're going to repeat it a whole bunch of times. Layer. Chunks, we load a map chunk. We're running the chunk size here. I am trying to remember where I loaded the particular hack that we're loading here. So for those of you that weren't here when we were building the tile system out, there is a bitmap in the background that controls what these look like. So we go over here. Okay, I still need to clear some of these folders out. Okay. It is this one, I think. Yeah. So this is the map. We have the rendering of it in here. This is a 32 by 32 block. And what we do is in the actual JSON that describes this map, we say which tile sets correspond to which colors. Then when we're loading up the map, we create a kind of master tile atlas, feed that into the Godot tile map layer, and then plot it out, where we know precisely which tile to put here. We were using the tile map layer's auto-tiling logic to determine which tile to use, but that was slow. Like, prohibitively performance intensive. It is actually faster for us to take this image, take those colors associated with it, process every tile in it, and say, okay, given what we know about all of the surrounding tiles, which tiles should we use? And make a secondary bitmap for that that is a precision match to it. You'd think that would be a mess. It's not. It is way faster. But now I need to find that code. Yeah, and this will be a matter of tweaking how fast, because there is a bit of stutter in this. We can make it cleaner by going back into Entity, finding the end step, and removing this little guy here. It's still there. It's kind of ugly. But I think we're still in pretty good shape there. But that's also a constant we can tweak. Find just the right value, you know? Okay, where did I put that mess? This one. Colors, textures, and we only load chunk 0. There's a point at which we are going to be loading in which precise one we use. So I'm trying to hunt down where I took the map image and convert it into a different image. Okay, that's map atlas. Okay, here we go. Okay. So we are creating an image. We're taking the first chunk that we've got, and we're getting the image for it. This is our hard-coded make it work that we were doing. So we take that one, we make a new image, or we get the image from it. We are going to extract height, width, all of that kind of goodness to make a new empty one that matches the formatting. Don't really care about the formatting matching, but we're rolling with it. Then we're going to take that data about which color lines up to which tile set, and get that in here. Now we're going to go through and we're going to check all around that tile. Since we know we have our core image, our world map tiles image. People ask questions all the time, Cruel. I don't really keep track in that regard. Try to treat everybody's questions that are polite to the same degree, you know? Terrain colors. We're looking at our world map tiles image and then our world map tiles. Just not the greatest naming convention, but here we are. The music video to that particular Daft Punk song is kind of surreal because of the effectively a skinless animatronic human. So it's got the like metal lip bars and exposed like eyes, that kind of stuff. Bit of a nightmare creature, but it's essentially the stand-in for the singer in that music video. Ah, okay. That's right. Curiosity. Yeah. Okay. That's right. That's right. That was actually something that I did before the stream today, Sublime. Let me... Shadows. So the little shadows under the sprites are drawn in circles. Doing it this way, drawing a circle on the node, this is actually really expensive. Like, really, really expensive. If you do it repeatedly. So the circles currently for those like little bouncing balls get smaller. The shadow gets smaller as the ball gets higher into the air. Oh, yeah. But if I do a redraw, if I cue a redraw for the next draw frame, like I trigger this on draw, every time the ball moves higher or lower, this was actually taking up a majority of the code runtime once the balls were in the air. I ended up changing that such that instead we just update the scale of the node that the circle is drawn on. It's not flawless. Like I said, there's a bit of an optical illusion going on, or a weird kind of smearing that happens with that circle, but it's cleaner. Ultimately, this is another thing that would be moved off to the render server code once we circle back around to that. Because having moved all of this stuff over to node logic, it will be a smaller leap to move it back into server logic. Again, this is Godot server, not like multiplayer server that I'm talking about. Completely different. Here's my tile renderer. So this creates our world map tiles. We're looking at our underscore world map tiles. Okay. Then we're loading chunks. We need to view it as world map tiles. So when we're loading a chunk, that's what we want to look at here. Fundamental breakdown here. Hey there, Galactics. Tricky syllable combination there. Doesn't roll off the tongue. That tiles. I'm currently hunting for where I introduced the hack. Because all of this is largely irrelevant now. By having the entire map, even if it's divided into chunks, I just need to say, take this chunk and render it to screen. Exactly, Tass. Getting this to work was a hatchet job at the time. So the terrain tiles are still useful. We have to be using... Okay, get pixel. further hatchet work, but testing. Definitely got some chop going on here. We'll have to clean this up a little further. Just want to make sure that I don't. Okay, that is our allow slightly more frames per second. There we go. Less stutter. Not going to be as optimal, but again, that's a number that we can mess with. Okay. Rage baited by my cats? I mean, I've had to haul Sky away from things and similar. Molly and Sky. Sometimes I need to, like, move them to a different position so they're not, like, blocking everything. But I wouldn't say rage has ever been in the equation. Well, I think my brain is slowing down, folks. Like I said, bit of a sleepy day, so I'm probably going to call it a bit early here and wrap up for now. We will be aiming to continue either a little bit more this week or into next week. I do still want to get some more creepy games into the loop. I just have to find ones that will, you know, last a whole stream. But for now, I hope you had a good time watching with us. If you like what you saw and would like to see more, remember to like, follow, subscribe, comment. All those buttons that are generally platform specific, press them, it helps. If you'd like to consider financially supporting the channel, you can do so through platform-specific means like channel memberships, subscriptions, and the like. On YouTube and Twitch, I do have custom emotes and such that you will get access to. There are also off-platform things like Patreon and Coffee. You can find links to all of my channels in my profile and in video descriptions. There is a link tree that goes to all of them. But with that said, I hope the rest of your day is good, and I'll see you